Hello, my name is Dennis Brimore, data scientist. I recently did a project on government workers' productivity, and I'm going to run through my project. It's not going to be so much of a lengthy video, so please follow me and scroll down the Python code. So I use the Google Colab, as you can see, and the libraries that were important to necessary to the delivery of my work. They're all here. So you can find them in the links that will be shared with this video. Uh, my LinkedIn profile, my Medium posts, everything you want, GitHub, where the codes are, they're all there for you to one peruse. Okay, so working with that set, what I needed to do was to first of all import the libraries that were needed. And after I put a library, just show what I'm going to work with, the data set. After reviewing the data set, you can see right away from the beginning, I want to check are they categorical data or are they numerical data? So what I found out was uh, this is 691, where every other one was 1,197, which means some data inputs are missing here. So check this out, it's still here again, ARP. So the visualization that I used, you can hover over it and to give you more statistics about the mean, the median, the lower quartile, the upper quartile, as the case may be, and even the histogram, as you can see, give you the counts and all what you want to experience from there. So this did not, I've summed up all the enough from all the input variables, that's the columns, and you can see 506 is missing from the way up. So what I did was to look for that missing one. What was peculiar about it? So when I saw it, you can see this is WRP. All the not a number, you can see they're all here. Uh, Going through them, looking at anything peculiar, it's nothing really peculiar, but they're just missing data. So I fill them with zeros, which the code around here. So checking them again, you can see they are all zeros. So no more missing data, fill zero. So you can also, depends on what you're working with, also decide to do maybe mean and so on and so forth. I set the feed up with zeros. Then the quarter five, as you can see here, this last bit here. Wow, sorry, so everything being highlighted. So as you can see, this quarter five is not to be 4 quarters, that's 4 weeks. That's the of the quarter. So I wonder what the fifth one came from. I can see so tiny, 3.6%. I did my findings and I discovered that the quarter five was actually the remaining part of the month. So we have the first to seventh, 8 to 14, as you can see here, 15 to 21 for the third week. So anything beyond 28 was named quarter five. So what I started to do was, okay, the best let put the quarter five, quarter four together. So it's just like an offshoot of the fourth week. Actually, it's going to be week, but it is what quarter, but it's okay. Looking at also the data for value count for day, discovered there is no Friday. So this shows that they don't work on Fridays. And the intensity of work, the productivity intensity, the target to be met. You can see 75% here. Let's see if I can highlight that. Okay, you can see here 75% and 72%. Now I can see the intensities on Saturday. They work so much on Saturday because they rest on Friday. They don't work on Fridays. So they don't work on Friday. Most likely Friday is going to be a holiday for the total factory. And maybe they have their reasons for closing down on Friday. So the idle time was 18 times the factory shut down for idle time. But were idle people while they were working, was there idle time to check if the data set make a lot of sense? So idle men were when they were working, was there idle time? The answer was zero, which means yes, there's no inconsistency because if people were working, it says idle time, then they have a problem with the data set. It should okay. So, like I said, I don't want to make the video so long. So this is part of the visualization. There's so much information there, box plots, target variable. You can see just hover around it, you're going to get, you can see when it's scattered, it's tiny here, scattered is big tiny, but the center is massive. So you have the median and all the quarters they're working. Okay, so that's the volume plot. So we'll go down to a lot of visualization, looking what's happening with data, checking if there are outliers that is going to influence the work one way or the other. So if the outliers are there, you can get rid of outliers when they are singletons, when they are just so few compared to the entire data. So they don't influence data wrongly. So outliers can tend to give a skewed view of what is really happening in the main data. So after I've done all I've done, then I use smooth, as you can see, for oversampling to balance the target variable. Okay, then I started working on visualization of the importance of the columns. Columns. So yeah, you can see the smooth oversampling was for the X actually. Was for the X. So whatever we need for the training part. So whatever it targets is preserved, but the training part can be worked on over something. So we have some data. So the video should not be too long. More visualization, trying to see what's happening there. Then the work starts. The models I started using. Uh, so the models started with Gaussian process classification. I did another the classifiers Gaussian. Those to show the pattern of how the models are selecting and picking their work. Each model have the pattern which they are made to work due to the mathematical calculation behind the scene, but also how does it work? What space? What format? How does it pick in the space that is working and how it's going to be working? So that we'll see at the end of the day. Now, geometries. We have so many models. It's too long. There are so many models, so many visualizations. Um, so get to the end, you see, yes, this is the Gaussian visualization of all the models being used, how they work. Uh, then, of course, you must give kudos to the people that give the code. So this is how the log marginal likelihood of different kernel. This is the ROBF kernel, this is the dot product kernel, the signal. And see how they work. You know, to select and get accuracy of movement. Okay. So at the end of the day, we we are having the garment workers So for the garment workers, productivity, merit of a medium, the problem at hand, data sets, the meaning of all those input variables, as you can see, what I got from all of it, without boosting, and then they handle first and like GB and give me 81%. So overtime became the most important for the workers. But clearly, workers love overtime. They also love incentive. The amount allotted for the production was also one of the motivating factors, which means they have some more time to make sure they meet their production quota. You know, work in progress. Other performance, what does it mean to the HR and equipment, manufacturing efficiency, policy making? It shows that this is what the workers, well, this is I think that will drive the workers and to make them more efficient. So multiply efficiency to boost the efficiency, to reduce costs, minimize disruptions also, and of course the policy to make to give insights on how the company will be run. So these are the works I did, and you can go and check them out in my Medium post. So with this, I'm gonna say thank you. So so it is I did go to my Medium post, so you can get the whole works there, everything that was done. So I say thank you.